Welcome back to geometry class. Today we are going to start a new unit on similarity. And the first part of our unit is going to focus on something you may have had some experience with before, and that is called ratio and proportions. So that's where you've got some fractions like a over b equals c over d. One fraction equals another fraction. So you may have learned some different ways to solve a problem like this, and that's fine. You're definitely free to utilize things you've used in the past if you find them helpful. But I'm going to present a consistent method for solving problems like these with you now. So we're going to start here with this easy problem number 2, which has 3/8 equals y over 24. So I like to use the method of cross multiplication. So you multiply the 8 times the y and the 24 times the 3, and then you set those products equal to each other. So let's say 3 times 24 equals 8 times y, which is just 8y. And it would have been just fine to write 8y equals 3 times 24, so have these on the reverse side, that's fine too. So we're going to multiply 3 times 24, which is equal to 72. And then to get the y completely by itself, we have to undo the multiplication times 8. So we divide by 8 on both sides. Whatever we do to one side, we do to the other side. And 72 divided by 8 equals 9. So y is equal to 9 for this problem. All right, let's try one that's a little bit more advanced. How about number 3? Okay, so on this one, we don't just have like a single y, the variable isolated already. We have x plus 22 on the top, and we have x plus 2 on the bottom. So we've got the variable in 2 locations, and it's not even by itself. We're still going to solve this problem the same way. We're going to take x plus 2 and multiply it times 30. So if I do that, the x plus 2 needs to go in parentheses to hold that piece together. So x plus 2 times 30, because we're multiplying the whole denominator times 30. And then on the other side, we're doing x plus 22 times 10. So again, the x plus 22 needs to go in parentheses, and we multiply that times 10. So we now have to use a skill that we learned in Algebra 1 called distributing. When you multiply something times a sum in parentheses, that number or variable that's outside has to get multiplied by both the terms inside the parentheses. So this is going to be 30 times x, which is 30x, and then we put the plus 30 times 2, which is 60. We're going to do the same thing over here on the other side. 10 will multiply by 22, and 10 will also multiply by x. So we'll have 10x plus 220. Now we're going to solve this algebra equation. We need to get our x's together on the same side of the equation. I like to move them to whichever side has the bigger x. So I have a 30x and a 10x. So I'm going to move them over here where the 30x is. So I will subtract my 10x from both sides. 30x minus 10x equals 20x plus 60 equals 220. And now I want to get my constants together, my regular numbers together on the side away from the x. So I'm going to subtract 60 on both sides. So 20x equals 160. And then the last step to getting the x by itself is dividing both sides by 20. So x is equal to 8. All right, let's go over here and do number 4. This one is easier than the last one. It's more like number 2. We're still going to solve it by using cross multiplication. So 18.2 times 9 equals 3 times y. And so you might want to grab a calculator to multiply 18.2 times 9. That's going to give you 163.8 equals 3y. And then to get the y by itself, we'll divide both sides by 3. And again, maybe with a calculator, 163.8 divided by 3 is 54.6. That's the answer for y. Okay, we're going to try number 5 next. So we're going to cross multiply 8 times 5 equals 4 times, and then we have the 2x plus 3. Remember, whenever you have that plus, or if it was a minus, you need to put that part into parentheses. So 2x plus 3 inside of the parentheses. 8 times 5 is 40. And then because we have the number out being multiplied outside of the parentheses times this binomial, we have 2 terms in here. We have to distribute the 4. So 4 times 2x and 4 times 3. 4 times 2x is 8x, and we put the plus in the middle. 4 times 3 is 12. And now I want to get x by itself, so first I'm going to subtract 12 on both sides. 40 minus 12 is 28. That equals 8x. And then we have to divide by 8 on both sides. 8 does not divide evenly into 28. That x is going to equal 3.5. Okay? All right, we have one more to do on these proportion problems. Number 6, I'd like you to pause the video, try this one on your own, and then play it again to see if you got it right. All right, was that one hard? It should be a lot like number 3 up here. You're going to multiply 3 times x minus 1. Remember, the x minus 1 has to go in parentheses. And 4 times x plus 1. Again, the x plus 1 has to go in parentheses. We distribute the 3. So 3x minus 3 equals, and distribute the 4, 4x plus 4. Now we need to get our x's together on the same side. So minus 3x on both sides. Now I'm going to jump down here. Negative 3 equals 1x, or just x, plus 4. And then to get the x all the way by itself, we'll subtract the 4 on both sides. Negative 3 minus 4 is negative 7. Is it okay to get a negative answer? In this case it is, because we're just working an algebra problem and answers could come of any type of number really. Sometimes in geometry it doesn't make sense to get a negative answer if we're talking about the length of a side of a triangle, for instance, but for this particular problem it's fine. Okay, now that we have learned how to solve proportions, let's talk about similar polygons. Similar polygons have the same shape, but not necessarily the same size. So the word congruent is a word that we've been using a lot this year, and that was same size, same shape. Similar means same shape, but not necessarily the same size. So you might have one that's a little bigger or smaller than the other. And this is the similar symbol. It looks kind of like the little squiggle that we put on top of the congruent symbol, but there's no equals because the sides don't have to be equal to each other when we are working with similar. So this is the same shape, but not the same size. So this word, this little symbol means is similar to. Okay, so let's jump down here and look at how this will work. This says list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. So we're going to skip number 1 and go to number 2 here. It says that the shape PQRS is similar to TUWS. x. So this is the similarity statement. And it's very important because the order of the letters here matters. The matching angles are in matching places, kind of like when we did our congruent statements earlier this year. So on similar shapes, corresponding angles are congruent. So this means angle P, the first letter, will be congruent. We're going to use the congruent symbol because it's the same size as angle T. So angle P and angle T are congruent angles. Now the second letter, Q, goes with U. Angle Q is congruent to angle U. So this angle Q is congruent to this angle U. Now, the third letter, R, is congruent to the third letter, W. So I'll do 3 tick marks here and 3 tick marks here. And finally, the last letter, S, angle S, is congruent to the last angle listed here, angle X. So this angle, 1, 2, 3, 4, is congruent to this angle, 1, 2, 3, 4. All right? So this is how we list all the pairs of congruent angles. Now, the next part is to write a proportion. So a proportion is where you set up your fractions that are equal, that relates the corresponding sides for each pair of similar polygons. So what does that mean? Well, let's start with side PQ, the first 2 letters of this shape. PQ is going to match up with the first 2 letters from the other shape, TU. So if I take PQ and divide it by TU to make a fraction, that fraction will be proportionally equal to QR, which is the middle 2 letters from this shape on the left, over divided by UW, the middle 2 letters from the second shape over here on the right. And now we've got 2 more pairs of sides to match up. The last 2 letters, RS, from the first shape are proportional with the last 2 letters, WX, from the second shape. And then 1 last pair of sides to make a proportion out of. The first letter with the last letter, PS, divided by the first letter with the last letter, TX. Okay? So these are proportional sides. The corresponding sides are proportional to each other. Okay? And we will actually be solving equations with that here in a moment. So the next little section here says determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. So this word scale factor is new. This is what you multiply by to go from one shape to the other. Okay? So for number 3, do these 2 shapes appear to be similar? Remember, similar means same shape, so the angles would be the same, but not necessarily the same size. The interesting thing about that is congruent shapes are also considered to be similar because they are both the same shape and the same size, but they don't have to be the same size to be similar. So for this first problem here, does it look like these 2 have the same shape? Are all the angles the same? I don't think so. There's a right angle on the second shape here, and none of these are right angles on the first one. So we're going to write not similar. There we go. And we're going to say not all angles are congruent. Okay, the angles have to be congruent for them to be similar. Now let's take a look at number 4. We have overlapping triangles here, PQR and PST. So are these triangles similar? Well, I can see the left angle on both is marked congruent. They overlap at angle P, so obviously angle P is the same on both. And then angle R also has congruent angles. So since all the angles are the same, we're going to say yes, they are similar. And then we have to write the similarity statement. So we'll say triangle PQR is similar to triangle PST. And remember, the order of the letters does matter. The matching angles, like Q is the same as S, both have to be in the same place. So those are the middle letter on both. And R is marked the same as T, so R is the last and T is the last. So the order does matter. Now, if you had called it to begin with triangle QRP, that would be fine. Then the next one would be STP. Okay? Now, let's talk about the scale factor. Notice the bottom side of the small triangle has a length of 11, and the bottom side of the big triangle has a length of 22. So what are we multiplying the sides by from the little triangle to get to the big triangle? 11 times 2 is 22. So we're going to say that the scale factor is equal to 2, because we would take the sides of the small triangle, double them to get the sides of the big triangle. All right. Next, we're going to have some fun problems to work on. The directions here says each pair of polygons is similar. So on the last problems, we were trying to figure out if they were similar. On these, they are telling us in the directions that they are for sure similar. And we have to find the value of x, okay? So let's see how that's going to work. Oh, and my copy is not very good here on the right. This is a 9. That doesn't look like a 9. It looks like a G. Sorry. It's supposed to be a 9. We'll just rewrite it. Okay. So these two triangles are similar. We're going to write a proportion to figure out how big x is. They want us to find the value of x. So the way I like to write my proportions, and it certainly isn't the only way to write them, but I kind of like to maintain a consistent method, is I like to go little over big equals little over big. So the first thing we need to figure out is there should be a pair of sides where you have a number on the little shape and a number on the big shape that match up with each other. So that's what I like to start with. Like, I'm looking here, they're not sitting the same way. It's like they took this and flipped it around, because this looks like a right angle down here and this is the right angle here. So notice the side with the 8 is between the one arc angle and the unmarked angle. And the side with the 12 is between the one arc angle and the unmarked angle. So these two go together. They're the matching sides, corresponding sides. So the little triangle has the 8 and the big triangle has the 12. So little side 8 belongs with big side 12, okay? Now, we have to find x. X is on the little triangle here. So little side x goes with which side on the big triangle? Well, we hope it's the 9, because it's the only other number we have. But the double arc and the no mark angle are surrounding the x, and this is the double arc with the no marks angle surrounding the side with the 9. So this side 9 does correspond to the side x. So little side 8 matches with big side 12, and little side x matches with big side 9. So it's very important that you set up your proportion correctly. I will tell you there is more than one correct way to set up the proportion. And as long as you are matching up matching sides when you set up your proportion, you should end up with the same result. If you did not get the same result setting it up a different way, then your proportion is incorrect, because all the correct proportions will yield the same answer. So now that we have our correct proportion set up, we can cross multiply. 12 times x equals 8 times 9. So 12 times x equals 72. And then the last step is to divide. Cross multiply and then divide. Divide by 12 on both sides to get the x by itself, and x is equal to 6. Okay, let's try another one. It's really important that you understand these problems, because we're going to do a lot of them in our unit on similarity. The method will be very similar from day to day. Okay, so let's look. We've got a couple of trapezoids here, and it looks like they're sitting the same way. We have the one arc angle here, the one arc angle here, the double here, the double here, the triple here, the triple here, and the 4 arcs here and the 4 arcs here. So they're sitting the same way. So I want to set up my proportion with my little over my big. Okay, so I need to look at these two shapes and go, where do I have matching sides that both have a number on them? Because I'm going to need those. See, I have a number here, 2.5, but I have no number here. So that number 2.5 is pretty much useless. We're not going to be able to use it. On the bottom, though, we have a 10 here and a 5 here. So this is good. These are the matching sides that both have numbers. So we're going to go little side 5 goes with big side 10. And then my x obviously has to be in my proportion. That's what I'm solving for. So little side x goes with big side 4.5. And now that I have this set up, and the 2.5 is totally useless, they often give you extra information that you won't need in the problem, so you have to know what to ignore. We can go ahead and cross multiply and solve for x by dividing. So it'll be 10 times x equals 5 times 4.5. So let me come over here. 10x is equal to 5 times 4.5 is 22.5. And then we divide to get x by itself. Divide by 10, divide by 10. X is equal to 2.25. And that's the answer for number 2. All right, let's go down here and try number 3. If I can get my paper situated correctly. So for number 3, I have my little shape here, and I have my big shape here. And they look like they're sitting the same way, which is helpful. So I need to look at these two shapes and find where do I have an actual number on both shapes that I can use. So on the left side here I have a 12, and on the left side here I have an 18. Those are matching sides, corresponding sides. So I'm going to go little side 12 over big side 18. Now where's my x? I have to have my x in my proportion, so it's right here. Little side x plus 1 goes with big side 24. And that number 18 won't be used in the problem. So we're going to cross multiply. 12 times 24 equals 18 times, in parentheses, x plus 1. Anytime you have the plus, that part has to go in parentheses. So 12 times 24 is 288. And then we'll multiply the 18 for both of these. So 18 times x is 18x, plus 18 times 1 is 18. Now we have to solve this equation for x, get the x by itself. So we'll subtract 18 on both sides. 288 minus 18 is equal to 270, and that equals 18x on the right. So then the last step is to divide by 18 on both sides of the equation to get x by itself. 270 divided by 18 equals 15. All right. I recommend that you pause your video and try number 4 on your own, and then play the video to see if you got it right. Okay, so the little shape is on the right, the big shape is on the left. And I'm looking for a matching pair of sides with numbers on both. So I've got a 30 here and a 40 here. So I'm going to go little side 30 goes with big side 40. And then I've got to get my x in my equation. X is on the big triangle this time, so it's going to go on the bottom, x plus 15, and it matches up with this side 18. The 36 won't be used at all. We're going to cross multiply. So 40 times 18 equals 30 times x plus 15. 40 times 18 is 720, and we'll distribute the 30, so 30x plus 30 times 15 is 450, and then we'll subtract the 450 on both sides. 720, minus 450 is equal to 270. And then we'll divide by 30 on both sides, so we get that x is equal to 9. All right, hopefully you got that one right. This will be our last problem today. It says, if ABCD is similar to PQRS, find the scale factor of ABCD to PQRS and the perimeter of each polygon. Okay? So, in order to find the scale factor, you're saying, well, what would you take the little one and multiply the sides by to get the big one? So, it looks like we only have one number on the big one. The bottom side is 25. They did not give us the bottom side on this one, but notice it's congruent to the top one, so it should be 20. So we're saying, what do you multiply 20 by to give you 25? So 20 times what number equals 25? How do you find that? Okay. So the way you find the scale factor is you take the new shape and divide it by the old shape. So we're starting with this one, we're going to this one. So the new shape is 25, the old shape is 20. So we do 25 divided by 20. And that is equal to 1.25. And you can check it. Take 20 in your calculator and then multiply it times 1.25 should equal 25, okay? So now they want us to figure out the perimeter of each polygon now that we know what the scale factor is. Well, the perimeter of the first one's going to be pretty easy because we just add up the sides, we know them all. 20 plus 20 plus 14 plus 14. That perimeter will equal 68. And then for this one though, we do know the top and the bottom are 25, but we don't know how long the left and the right sides are. So we have to figure that out. How do we figure that out? Well, we can take the old shape 14 and multiply it by our scale factor of 1.25 to give us the length of the new shape side on the side. Left and right here. So 14 times 1.25 is equal to 17.5. So this is 17.5 and this is 17.5. So now we can add up the four sides of the quadrilateral here. 17.5 plus 17.5 plus 25 plus 25 to get the perimeter, which is 85. Okay, so we found the scale factor and we found the perimeter of each polygon, the first one and the second one. All right, that's all I have for you today. I hope you had some fun learning about similar polygons. Good luck on your assignment. Please let me know if you have any questions or need help at all. And I will talk to you again soon. Have a great day. Bye-bye.